So here we are in the lab again, and so last time we found that we had a signal that was supposed to be low, but it was being held high, and it's not shorted to VDD. So I think I know what's going on. So let's jump over to, well, let's take some measurements on the board, and then we'll jump over to the schematic and we'll check it out, because I have a feeling I know what it is. All right, so now if we look at the schematic, so the signal we're having a problem with, see when one of the address lines, the address, we're going to call this address select line. So when I say address select line, I mean the one that's active from this address over here, selecting it, so it would be low. So when our address select line goes low, depending on the jumper, it's gonna pop this one here low. This one goes out to the microcontroller. We're not worried about that right now. So this line right here is being held high by something. So it's one I was looking at. Before I say anything, let's check this chip enable line here, this read write, and this output enable right here. These three lines. So this is 1, 2, 3, 5, 6, and 7. All right, from the top. 5, 6, and 7. All right, so let's go to the board and check that part out. All right, so now we know that it's 5, 6, and 7. All right, of the IO connector. So we got, so we're going to go, if I can keep that out of your guys' way here. All right, so we got 1, 2, 3, 4, 5. All right, so 5 is low, 6 is high, and 7 is low. All right, so now let's go to our schematic. So what we have is we had a low, high, low. All right, so this is the chip enable for this side of the SRAM. So let me pull up the data sheet on the SRAM so you can see what the deal is going on there. Okay, so here's the block diagram of the SRAM. 8K by 8 dual port static RAM. So this is on the RAM resides on the main brain board, and main brain uses the right hand side. There's two sides, the left and the right. Main brain is on the right hand side, and our IO card is on the left hand side. So it's what we're worried about is actually these three signals are together right here that we're worried about. So we measure this on the board. So the output enable, well, the chip enable was low, and the output enable was low, and the read write was high. So it's what that is saying, that the SRAM thinks that we asked it to turn on, which is the select, the chip select. So all of the data lines went from high impedance to the active state, right? So then the output enable, since it's low, it is sending data out. So all these 8 data pins are being driven by whatever's in the memory location. And if it's blank, it's probably FF hex, which is all high over here. So we're driving highs out, all right? And so the read write is high. So then it is definitely putting data out. And so it's what the problem I think is that since we're enabling the chip and we're doing the output enable as low, then it's sending the signal and it's driving against the AC 245 bidirectional bus transceiver. So they're butting heads with signals right there. So one of them can be damaged or both of them could be damaged. So that's kind of a mistake in design, because it's what I think we're going to have to do is we're going to have to, we'll go back to our schematic here, and we're going to have to run a resistor at least on the chip enable and pull it high, resistor to VDD. We're at least going to have to do that. And so let's take and copy a resistor right here. And we'll rotate it right here like that. And so we'll bring that down to chip enable. And then VDD, let's see, do we have one up here? Yeah, so we can just do it like this. Okay. So we'll get that on there. So save it. So that's the first thing we want to try. We want to get that stabilized, because chip enable should not be low until we tell it to go low. And only the microcontroller does that. So there's no microcontroller, so we want that to default to a high state. And we may want to do that here, but let's get a resistor on here and pull that signal high to VDD and see what happens. I'm afraid we're going to have to probably pop off this chip here, the 245 chip. I think we're going to have to pop it out of there, because I think it got damaged, and I think we should probably just pop it off anyway so we can measure the signals and eliminate the possibility about that anyway. So let's go to the microscope and we'll get a resistor on there and pop this guy off of here. So I'm gonna take off this chip first, because I want to get it off of there, and it's possible that it's kind of fried or broken. So in order to do that, there's a couple ways. You could use a heat gun, but it's such a small chip and the pins are so close together. I'm just going to dump on some flux here. My thing's plugged up. There we go. All right. Flood it with some flux, and I'm gonna get my solder here, and I'm just gonna blob solder on both sides of this chip like this, so that all the pins are connected together. All right. And then I'm going to get my tweezers ready. And then I'm going to heat this bad boy up, just like this. Let it sit there, not too long, but it's got to get everything reflowed. And we got to jump to this side. Got our tweezers ready. So we got to get it hot enough that one side stays hot until we reflow the other side. All right. So we should be able to grab it without too much problem here. Yeah, it moved, but my tweezer slipped off. So maybe we can just push it like that. There we go. There we go. Okay. Got it with our tweezers. And we just put it over here on our thing, our sponge, to dry off. So we did it pretty good. It's clean. It's clean enough for right now anyway. All right. So let's clean that flux up before it gets too dried and hard. And we can reuse that chip too if it's good, but we don't know. So we'll probably just replace it. That's why I ordered 2. I should have ordered maybe more. But I think we're okay. We just got to pay attention to the outputs. All right, see how that flux puts a residue on there? And you turn the Q-tip over and you wipe it again. But I mean, it takes some cleaning. But like I said, electrically, it doesn't even matter. So we'll get this all cleaned up. All right, so there's that. So now we'll flip the board over. And we got to find where we're going to put the resistor because it has to connect the chip enable pin, which is number 5, pin 5 on the I/O connector. And it comes over to here. But I think we'll just stick a resistor right onto the pin, and then we'll run a jumper up here. It's going to be hard because the jumper's on the other side where we need to be. Let's take a quick look at our PCB in Fusion and check out the traces, see which is the best route to go here. Okay, so then when we added that resistor, then they've added it into the PCB. So let me drag that into place here. See where we can put it. I think that would be a good place right up in here. Just pull it up in here like that. Turn it around. Something like that. And I want to get rid of that for right now. Oh, not that. Get rid of those big letters. Get that out of our way. All right, so there's our resistor. That's a good place to put it on the board. So let's just do that real fast while we're here. And let's see, this one will be a good, just a little circular deal here. Nice little curve. I like that. And that's got to come over to this one here. That's going to be a fun. So let's just do this real fast. Copy that via right here. And run a bottom trace over to this one. That's like that. And looks like that should work. Back to the top. Let's get a trace here. From here. Over to there. Let's just line this via up real quick and we'll be done with that. Okay. All right, so that should be that. And we'll save it. And if it turns out we don't need it, which I'm pretty sure we do, then we'll just delete it out, no big deal. And you know what? I just want to move this one thing right here. It's this one. Oh, that one. Maybe we can't. Oh, I see what happened. I have my thing turned on here. So I don't know what this is, but we got to get rid of that. where it's going to get us. All right, so let's do this. Not that. We want to move it. We're going to grab this. We're going to move it to a better location, like over here. This via just connects the bottom and the top ground together. So it's still too tight in there. So that looks good. I like it. So that's going to be our next revision. On our next revision, it looks like. So, yeah. All right. So now, for putting it on our board, we're just going to have to stick it on this pin right here. So I'll put our eyeball on. And so, we could, VCC is right here, or VDD, I mean. So we could actually stick it, well, we added that one. So let's just stick it here and run a jumper to VDD. So let's just stick the resistor on the board right here, solder it to this pin of the connector, and we'll just run a wire from the end of the resistor over to VDD. All right, let's do that. Okay, so now we know that the resistor has got to go on pin 5 of the connector. So let me grab a resistor. I'm going to grab a 10K. Let me grab this big one out of the bag. Okay. And we'll dump one down on here. Okay. Very good. Put that up there. Let's see if I can turn this over. I don't know what that is. Let me clean off my tweezers a little bit. Okay. See if I can get this thing flipped over without flipping it back over. All right, there we go. Okay, so I'm going to try to come in here with the tweezers like this. Whoop, there we went. Okay, try it again. So I'm going to try to get the tweezers in here like this. And I can't. The microscope is in the way to do it that way. So I have to come in here. We'll dump a little bit of flux on it. Not there. There we go. All right, so see if I can hold this thing down while I solder it. And there we go. That puppy's soldered. So 1, 2, 3, 4, pin 5. All right. Now we got to get a wire on there. Let's move this down a little more because we have to be able to see pin 5 and the resistor. I mean pin 1, VDD, and the resistor at the same time. Okay. So we'll get a piece of wire here. And it's such a small, short wire, too. All right, trim a little insulation off of there. So we're going to run our wire from the resistor, and we're just going to solder it like that and then loop it around to VDD. So So it's going to go about like that. And it's going to bend about like that. Okay. So then we got to trim that bad boy off of there. Uh-huh. This is a small one, folks. Okay. Now, let's try to get that thing soldered on there. I think I need just a dab of flux right there. And a little bit of solder on the end of the resistor right there. Like that. And so we're going to put that guy right on there like that. Okay. Then we got to try to bend this thing around, this wire here, to get to VDD. That could be interesting too. Without slipping and, yeah, I think I broke the resistor. See if it'll stick back on there. Sometimes it'll pull off the coating off the resistor and it won't stick anymore. Yeah, that's what we did. We broke the end off the resistor. All right, so we're going to have to put another resistor on there. So let's solder that to VDD like that. And we should have probably done that first. Okay. All right, so then that'll just come down here. We'll bend it like that. And we'll just put it on there kind of like that. So let's get that resistor off there. Getting it off is kind of easy. Just like that. Good thing they're not expensive. They'll pop off on you too. You'll grab them with the tweezers and they'll just shoot off into nowhere. Sometimes they're like $1 on some parts, but these resistors are like 10 cents at the most. Especially if you buy 100 at a time. All right, let's see if we can get that guy pushed around in here. Like that. I got to get that off by a tip. Okay, got a good deal there. I want to get a little bit of solder built up on the end of my resistor here. It doesn't hold too much, but get it on here. And if I can keep from moving the board so you guys can see it, we're just going to stick it on there just like this. All right. So it's on there. It's kind of ugly. It's on there. All right. Clean it up a little bit. Try to minimize the ugliness as much as possible. But it's a prototype board. I mean, don't expect to be perfect the first time. That's why they're called prototypes. All right, that should get us there. So now we'll plug it into mainbrain and we will check the signal now and see what it looks like. Because with this signal high, it should turn off the chip, the SRAM, so it doesn't send anything out onto the data bus. All right, let's go back over by mainbrain. Okay, so let's plug in our board here, the mainbrain, like that, and power him up. Connect our scope ground. All right, so we are at address 0. So A0 here on our pin should be low, and it is. So then all the next ones should be high. All right, pick a random one. It's high. All right, so we're good there. So let's come sneak back around to our problem pins. See what that's at. All right, so that one is still low. We have a problem. Oh no, wait. Oh wait. Yeah, that was being forced high, wasn't it? Yeah. So we're not high anymore. So let's check our pin right here. 1, 2, 3. Can you see that? No, you can't see that. Okay, 1, 2, 3, 4, 5. Let's check that. Whoop. 1, 2, 3, 4, 5. That's how we damage stuff. Pins are slippery. All right, so we're high on that pin. That's very good. And we're low on these pins. That's very good. So let's put our shunt on there and see what happens if we put it on the high side. So we'll put it on the second position. So they're both high, the way it would be if we selected a different address than what we have it set for. All right. So then let's move it back over to low. We know it'll go low. See, it's supposed to be low, and that's what we want. So I think we're pretty good. So let's jump over to our schematic one more time, and we'll check some. Well, we can check the data lines right here because we know these are from. If you look at the PCB, these are the data lines that switch to the bottom layer and goes to that 245 chip. So let's see what these are at. Yeah, and see they're low. And they used to be high. So the chip, so with this being high, this pin 5, that turns off the SRAM. So it's not driving any signals out. So we should check the 2 buffers on the top here because they're for the address. And I'm pretty sure I can see the traces here. So everything is low. Low. So they should be selected. Let's move our jumper and see what they look like. So that's making the chips, the address select signal high now. So that should put these at a high impedance state. we don't have anything hooked to that. So let's check out one of these here. It's still low. That one's supposed to be all low. So let's look at our schematic and get some address lines measured and see what's up with the address lines. Okay, so now we want to look at the address, which one pins are the address lines. So, all of these pins along here are address A9 through go all the way to A0. And that's all we need to know. Yeah. All right, so we got a reset and then A9 all the way down, huh? All right. And then for the data, we know the data, and I think it would be okay not to worry about these if we just measure these. So I got an idea. So what we'll do is we will take a resistor and tie it, put it on a piece of wire, and then we'll tie it to VDD, and we will deselect this to a different address other than A0, which will deselect these chips and put them in the high impedance state. And then with a 100K or a 10K resistor tied to VDD, if we touch it to the address lines here, it should pull them. Because if the SRAM chip is turned off in its high impedance state, then we should be a 10K resistor, even a 100K resistor should tie or should pull these high. If it doesn't, then the SRAM is forced into a low state since they were all low. All right, and then we'll switch it on up here at our jumper. We'll put it on A0 and select these guys. And then they should, the resistor should not be able to pull up the address lines. It should remain low, at least on this chip here, because these are being forced low from the other side. So I think that's a good test. And we also need to check our schematic real fast. And on our 244s, okay, so those both output enables are tied together, so we don't have to worry about it. Yeah, all right. So those are 1 and 19. And 1 and 19. This is 1, 19. So if we check that, yeah, we can check 1 and 1, pin 1, no problem. Are these tied together? Oh yeah, 1 and 19. Okay, so we'll check pin 1, and that's easy to do. So we'll check pin 1 and do the resistor trick, and that will tell us pretty much what we want to know. All right, so I have a resistor here, a 47K that I had laying around. So I tacked it to this wire here, and this wire is connected to the 3.3 volts of the power supply. And so we're going to use this as a probe to see if our chips are in high impedance like they're supposed to be. So let's get a little clip on the scope here. And we'll clip the scope on this side of the resistor, like that. And you see it's 3.28 volts. And so the scope will change to whatever value is on this end of the resistor. And so the idea is that the resistor, while using the resistor, we can probe the address and data lines, and if it's being driven low by another chip, then it'll stay low because the resistor won't be able to pull it up, and the resistor will drop the voltage across it. But if the line is in high impedance state, then the scope will go high or stay high because the resistor will be able to pull up a high impedance line because there's no real resistance, a very small resistance. So that's the idea. So we're going to check our signals and see what we have. So first, let's move the jumper over to 2, or well, address 1, so that our chips are deselected and should be in the high impedance state. And we'll check, we're going to check the data lines too coming out of the SRAM just to see, make sure it's turned off and it's in the high impedance state. So let's start with these address lines down here, because on this chip we are, see if I can make this so you can see it better. See how that's probably pretty good. This needs to move. Maybe we should move this. Yeah, let's move this on this side, huh? Do it like that. There we go. So then these lines over here are address lines, and on, if you remember from the schematic, this chip, the inputs are being held low. They're hardwired low. So we know that if this chip is turned on, it's going to drive these signals in here low. All right. So then when the chip is enabled or disabled or deselected, like it is now, then it's going to be in a high impedance state. So then if we touch it right here to this guy, then it's high. It stays high because it's in the high impedance state and there's no real resistance. Okay? So then we know that it's address 9 through 0 here, so we'll just go down them real fast, just for fun. So 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. So they're all in a high impedance state. Okay? So then, if we go over here and touch it to our address 0, it should go low. If I can make a good connection. All right, all right. There we go. Okay. So now let's check these data lines here that go to the 45 chip. Yeah, they look all high too. So that's what we want to see. So if I would have put a resistor on this thing to begin with, it probably would have been okay. All right, so all those guys look good. All right. So, coffee. So now we're going to move the jumper here over to our selected address. That should turn these chips on. And when we touch these address lines, they should all be, well, these ones here should be low. These probably will be high because that's what would be, let's see, where you don't have the output enabled. Yeah, the output enabled. Yeah, these will probably be high over here, but we just want to check these to make sure because we're not affecting, yeah, we're not affecting the SRAM. We're only turning on these chips. So let's check 9, address 9 right here. Yeah, see, it's being driven low. 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. All right, so our circuit's working right there. That's pretty much what we want. And so we check our chip enable just for kicks. It should be high because we haven't messed with that in any way. So 1, 2, 3, 4, 5 for that guy. Yeah, it's high. So everything's good. So now we'll put it on a new AC 245 and see what we get out of that. One more thing though. We can check like pin 1 right here and see what it is. So that's low, and then if we deselect it to another address, any address, it should be high, and it is. We're looking good, yeah. Okay. So let's get this off of here. We want to flip this over. Let's see, we can unplug the programmer. Flip this thing over like this. Let's get the screen on that towel. It's already beat up bad enough as it is. All right. Clip on our ground. All right, so pin 1 is up here. So we just want to take a look at pin 1 right now. Let's see. Our address is selected. So pin 1 is our direction, right? And it's high. Actually, we should probably check to see what it is without pulling on it. And it's high. See what these guys are over here. They're high. All right. Pin 19, that should be pin 19. That's showing kind of floating. That's not good. Our address should be low. What do we got going on here with that chip? Let's flip this back over real fast. So it looks like our address, even though it's selected low, it's being pulled up a little bit. Let's pull that off of here. So we got this guy's on low, and this guy over here is being pulled high. So they're fighting each other again. What is going on with this chip? All right, let's deselect the chip. Let's see what we get on here on the back side. This makes it a little more cumbersome. Um, and it's high, but it's not where it's supposed to be. All right. So this should be pin 19 right here. Well, it's high. It's high there. But our pin 1 is acting funny. I mean, it's high, but it should be really high. It should be 3.3 volts or real close. These guys here, outputs are being driven high. This is an input. Input is high. So I'm gonna have to pull up our PCB again in Fusion. Look at these traces, and that is really a bizarre thing to have happen. Okay, so I found our problem. Uh, it's a mistake in the schematic because if we look at the ground right here, it's tied to VDD. That's why. I'm sure the chip doesn't like that too much. Uh, Probably won't hurt it because there's no real potential. So I don't know. We'll see. But so if you come over to the PCB and you look at it, we can correct it on our schematic, but we got to correct the board we have. So we got to cut this trace right here underneath the chip. So that means we got to take the chip off, cut this trace here, put the chip back on, connect this pin to ground, which the next available ground is. I don't like to do that, does it? Let's see. Next to ground, it should be that one right there. This guy right here. So yeah, we'll just have to run probably from this via, we'll have to run a line over to here. That's a pretty crazy mistake to make. That's what happens when you do it in a hurry. But that's what we're here. We're here to learn. And we learned a lesson here. So let's change this and get our schematic straightened up. So we're going to just pull this to ground wherever. So this should be ground here. Yeah. All right, so we can just pull it out to here. So we'll take this off right here. Add this on right here. And yes, we want to merge that bad boy. That'll fix. That's the fix right there. Now we got to come over to our PCB. Let's flip this back over. I flipped it over earlier. I was looking. All right, so then that should change our chip here. See, it gave us a line. So we don't need this. That explains it because that was just so bizarre. So this BDD still has to get tied in. BDD here. It's locked in pretty tight too. Let's see, I can come around down here. I could sneak it in here, over to here. That looks like about the best thing to do. Let's grab this guy here. And looks like we can do like this, huh? Bring it down. All right, that should fix that. We can drag that down, get a little better clearance. It's pretty much in the middle. We'll just leave it. All right, so there's that. So then we have our ground over here. Oh, it automatically did it. And we're tied in good. So we're good there. We're good. Save it. So we fixed our error. And then while we're on the subject of the PCB, this one that we added in yesterday, I'm going to take this out, and this is going to get moved to main brain. So that way it will pull up all the lines from all the boards. Because if we add one of these on every single board, then if you remember Ohm's law, every resistor in parallel cuts the resistance in half. So that's quite a bit of cutting if you have 7 boards on there. So that's going to change a lot of too much change in the system. So we're just going to take this out, and we're going to put it on main brain so it can pull up the whole thing. So we'll just take this out. And I'll have that in MainBrain. And I think it's already in MainBrain anyway for the latest revision. Then over here, we're probably going to have some residual things here. Yeah. So we'll cut this out. All right. There we go. All right, so we found our problem. It took a while, and sometimes that's the way it works. Save this. Okay, so looks like this video is getting pretty long, so we're going to cut it right here and do a part 2 on the next video where we do the actual fixes. And yeah, so that was an interesting troubleshooting thing. That's the way it works. That's what we do in the lab. We make mistakes and we fix them and we learn from it and we make more mistakes later. But that's the way it is in a design. The design is not a smooth process like that. It's you come to walls and problems and you have to find your way over them, and that's just the way it is, and that's what we're doing here, and that's the whole challenge to the thing. And that's what makes it interesting, and that makes the reward even that much greater when you're done and you see your project doing something productive and working hopefully smoothly, and it's a great reward. It's a great feeling when that happens, but it's a long road from the concept to the finished product, and that's what the whole thing's about. So I'll see you in the next video.